Welcome to this session, How Data Shapes Artificial Intelligence. We'll explore the foundations of intelligent systems and the crucial role data plays in shaping their performance. This course is designed as a short video with interactive Q&A. It's a non-technical introduction to the role and importance of data in artificial intelligence. By the end, you'll have a clear sense of why data matters and how it impacts AI outcomes. Our learning objectives are simple. First, to recognize the importance of data quality, quantity, and labeling in making AI solutions effective. Second, to appreciate the role of ethics, bias, transparency, and policy in ensuring responsible AI use. Before we dive into today's topic, let's quickly recap what we covered in the previous video, Introduction to AI. Artificial intelligence enables computers to mimic human intelligence. Machine learning is a subset of artificial intelligence that learns patterns directly from data. There are three main types of machine learning: supervised, unsupervised, and reinforcement learning. And for more complex tasks, deep learning uses neural networks inspired by the human brain. This foundation sets the stage for understanding how data shapes artificial intelligence. Data is the foundation of artificial intelligence. Without reliable data, even the most advanced algorithms cannot perform well. Let's look at how statistics and data shape machine learning. Artificial intelligence is anchored in statistics, the science of collecting, organizing, analyzing, interpreting, and presenting data. Statistics provides the framework that allows AI systems to learn and make predictions. Data is the cornerstone of artificial intelligence. The quantity and quality of your data influences how trustworthy predictions are. For example, imagine training a model with labeled data to recognize apples. Each example has features like shape, size, color, and a label, such as apple. The model learns patterns from these examples. Quick check: which branch of machine learning uses labeled data? A. Supervised learning. B. Unsupervised learning. Or C. Reinforcement learning. Supervised learning is the branch that relies on labeled examples. Labels are the ground truth the model learns to predict. Training data consists of examples the model learns from. Each example has features like shape, size, color, texture, and a label, such as apple. Features describe properties, while labels define the category. Together, they teach the model how to recognize patterns. Basically saying that whenever you see an item that has these features, you must classify it as an apple. Machine learning improves with lots of examples. More data helps the model learn patterns better. But quantity alone isn't enough. If your dataset only includes green apples, the model may fail when shown a red one. Quality means diversity. Including apples of different colors and shapes makes the model more robust and less biased. Good quality data combines quantity with diversity to reflect real-world variation. Knowledge check: why does machine learning perform better with diverse data? A. It reduces bias and improves generalization. B. It makes the model memorize training data. Or C. It decreases the need for training data. Diverse data reduces bias and strengthens generalization. This protects against blind spots. Now that we've seen why data matters, let's look at model behavior. Poor models can lead to wrong predictions and classifications. Key concepts include underfitting, overfitting, and evaluation metrics like accuracy, precision, and recall. In artificial intelligence, poor models can lead to wrong predictions and misclassifications. That's why understanding underfitting, overfitting, and evaluation metrics is critical. Underfitting happens when a model is too simple. It misses important patterns, leading to high errors. In AI, this means critical insights are lost. Fixes include adding features, increasing complexity, or training longer. Overfitting is the opposite. The model memorizes training data but fails on new cases. It looks perfect on old data but unsafe for new predictions. Solutions include regularization and adding more diverse data. The goal is a good fit, a model that captures patterns without memorizing noise. Training error should be slightly lower than test error. This balance ensures reliable predictions. Every prediction falls into one of 4 categories: true positives, true negatives, and false negatives. In healthcare, false negatives mean misdiagnoses, while false positives can lead to unnecessary treatment. Accuracy measures overall correctness. Precision asks, of predicted positives, how many were right? Recall asks, of actual positives, how many did we catch? In healthcare, recall is critical. We don't want to miss sick patients. What does a false negative mean in healthcare? A. Predicting a patient is sick when they are healthy. B. Predicting a patient is healthy when they are actually sick. Or C. Predicting correctly that a patient is sick. A false negative means a sick patient was predicted to be healthy. Which metric focuses on catching as many actual positives as possible? A. Precision. B. Recall. Or C. Accuracy. Recall is about catching actual positives. To summarize, data is the cornerstone of artificial intelligence. Quantity and diversity together create trustworthy, generalizable models. Supervised learning relies on labeled data. Avoid underfitting and overfitting. Balanced models give reliable predictions. Evaluation metrics like accuracy, precision, and recall matter, with recall being especially critical in healthcare. And finally, responsible AI requires ethics, transparency, and awareness of bias. This is the end of this video. If you found this helpful, don't forget to follow, like and subscribe, and check out the other videos in our Introduction to AI and Machine Learning series. Links are in the comments below. Thanks for watching, and see you in the next session.